Hi everyone, welcome back. Lastly, we talked about the GFTT detector, and today we are going to talk about the KAZE detector. Actually, before starting to a new feature detector class, I want to compare them in a like this in a table. So I'm gonna update this table when we switch to a new feature detector, so we can easily understand and compare the other detector together. So okay. There are 5 categories currently I just divided, so maybe we can compare accordingly. First of all, this type of the KAZE was key point detector and the descriptor extractor. This is the important one because GFTT detector only the key point detector, we can say. Key point, just remember as corner, we can say. And what is this descriptor extractor? Actually, descriptor means for example, this KAZE or some other kind of feature detectors are not only detecting the corners, detecting the key points. They are also giving a description to each point. We can tell like that. So they are giving a descriptor for each point. So that points you can compare with the incoming for with other images also, so you can find the similar points between the images. So this is very important, but the GFTT detector does not have this. Also, maybe simply I can show you in the code part, because previously we already talked about GFTT, we didn't talk about descriptor in there because it doesn't have. Okay, scale invariant also, these categories most related to descriptor, because the incoming the other descriptors we are gonna talk in the future, they are mostly gonna have descriptor also, but that's why I added some other categories. Scale environment means, for example, a bigger image, I mean the high resolution image or low resolution image. Let's say both have the same object, or let's say both have the triangles but with different pixel sizes. It's still it's gonna be still able to detect those similar corners with and it's gonna give the similar descriptions for the similar corners, similar key points. That's the meaning. And rotation invariant also same, even the is vertical or horizontal, if the same object is gonna give the similar key points, similar descriptions for the for the target key points for each image. So that this GFTT, since doesn't have descriptor, both mostly they are no. So feature type also robust key points. Also I can say GFTT is robust, also useful for the industrial applications. Also from the name you can understand good features to track. For tracking some objects, this is an extra backend, can be as extra backend it can be used. It can be useful in some, because it's faster. And also I cannot say it's really bad, it's old. This is more modern, and also other descriptors are more modern, but this is still useful and handy in some cases. Okay, also descriptor support, we already talked this, yes, this is no. We can switch to the code part. I want to code from the scratch. Let's just call like pointer and KAZE. KAZE doesn't stand for anything, it's just a name, Japanese name I think, so I just already searched that, and it does not stand for anything. Okay, just KAZE, let's call it, and is equal to just KAZE and create. And as I did in the previous video, I want to talk about the these parameters in the next video. I will not focus on to this. I just want to make an introduction and make a simple I want to see the simple usage. Also, we were dealing, if the people directly watching this video, we continue with a similar image like this. Also, I want to create a name window to make it, oops, just to make it easily resize, and result and 0, which is normal. Okay, and KAZE we already create. We can also we are gonna need for to be able to use the detect function, we are gonna need a vector which is including the key point, and this is gonna be my key points. And now we can call KAZE function. Okay, and here just we need to call the detect function, which we already did previously. Also just giving as input image, it's 1 channel or 3 channel, doesn't matter, and give the key points. and it's done. And the next we can call the draw keypoint function, which is a handy function. Just we need to give the image, we need to give key points, so we don't need to deal with the for loop to see the output at least, and the image, and maybe we can call this color, which is our favorite color, yellow. And we are done. Let's see the result, how it looks like. Okay, you see these are, we are expecting the key points and the corners, but you see many missing points, also many wrong, it looks like at least, but in reality, of course, it's making a calculation. In here you see, in the previous video we talked, when we zoom we see corners. We do not see without zooming, but the backend still see, so we need to update the parameters, then it will give us the correct result which we want. But of course we are gonna talk about this in the next video. And in here we already talked about the descriptor. Let's talk about that a little bit. If you have this, you can simply just call also there is a compute function which is gonna give you the descriptors if you want. And here we need to give the image, we need to give key points, and also what else, we need to give descriptors, which is gonna be a math. Let's call it descriptor. Okay, just give that. I will not show the results, of course, but just to show you it works successfully, so there's no error, there's no crash. But if we go to the back, which is about the just simply recreate this GFTT detector like we did in the previous video. Sorry for recoding, and just GFTT, okay, and just calling GFTT is equal to CV GFTT detector and create. And here, if we are gonna need key points, we are gonna need descriptor. What else we are gonna need? Nothing else, just comment out here. And here I'm gonna call GFTT dot detect, which is I need again the image and the key points, and done. And the next I need to call GFTT dot compute. There is still this function in here, but let's see it's gonna work or not. Image, key points, and give me also descriptor. Okay, let's try to run. You see it crashes because this even it calls the function compute function because they are derived from the similar class which is feature 2D. In here this compute function exists, but it does not work for GFTT because it doesn't support it, as we talked in the beginning. You see, that's the meaning of this row. So the difference, the major difference of the KAZE and the GFTT detector is this. So yeah, basically I just wanted to show simply how this KAZE is working. We already initialized, we already talked about that, also we compared. In the next video we are gonna focus to do KAZE member functions, KAZE parameters, so these things. Okay, I'm done for this video. Thanks for watching, see you in the next videos.